Hello, everybody, and welcome to this new edition of SQL Saturday 2022. So I will be the first one presenting this morning. So I have also the honor to give you the welcoming to the whole event. So before starting, a couple of minutes more. I suggest you review the schedule because we changed something, and Sergio Govoni is going to present instead of the tip and tricks session this afternoon at 2 o'clock, a session about the new parameters handling by SQL Server 2022. So let's start with data integrity with SQL Database Ledger. First thing first. Who am I? I'm Gianluca Ozza. I'm an independent consultant on SQL Server, an old one. I've been working with SQL since more than 25 years, from version 4.21 back in 1996. So it makes really a long time. And I'm focusing on database modeling and development, sizing and administration, modernization, performance tuning, and of course security. So I'm kind of a DBA role. For the community, I'm a long time MVP, one of the oldest. It's 24 years in a row. And I'm also a VMware expert for SQL Server, and I'm founder and president of UGIS, which is the Italian user group for SQL Server, which is, by the way, one of the organizing partners, along with the University of Marche, and of course Danilo, that made all of this possible all of these years. So let's start with the topic. And let's talk a bit about ledger technologies. Why are we talking about these ledger technologies? Why they can be helpful? So many companies nowadays are trying to move from third parties, intermediaries that are running audits or manual audit procedure they are doing internally. Why? Because these are usually slow and quite costly. So companies are trying to move to ledger technologies to reduce both cost and save time, but also to lower the kind of risk associated with running this kind of audits. And just to give you a very broad picture of how big is all this stuff around ledger and blockchaining and things like this. So the blockchain market is it's huge, quoted at 25 billion by 2025. Not only that, there is a problem. Gartner predicted, made a research, and they found out that 90% of the blockchain projects, companies that are implementing this kind of projects, they have a complete misalignment with the blockchain technology, meaning that they are using blockchain when they could use something lighter, simpler, that can solve problems anyway without all the overhead of this of the blockchain technologies. So why blockchains are overkilled in some of these scenarios, especially in scenarios that require a kind of centralization. When you decentralize completely, which is the typical blockchain scenario, it is required that all parties that host nodes that are running the blockchain computation, they need to participate. They need to be available and participate to reach the consensus. Then another problem is that governance rules must first be established. So people need to agree on these rules. They need to be laid out. And so there needs to be a consortium that lays out these rules. And then they need to be deployed across all of the nodes and need to be managed because typically governance rules change over time. And so these introduce overhead, complexity, risk, of course. Another problem is the latency associated with this network consensus. This, of course, because there are many actors on the network, on different networks typically that runs at different speeds, and they may have latency for any kind of reasons at any point of time. So these have a direct impact on the transaction throughput that is achievable with this kind of technology. Just to give you a number, for example, we are talking about a little bit less of 1,000 transactions per second using Ethereum, which is one of these kind of technologies. Another big problem, and this is one that Ledger tables, as we will see, solves nicely, is that you have the blockchain, you have all of the data in the blockchain, and then you need to run some analytics on it. And this is very, very hard when not even straight infeasible. So querying the whole chain to do analytics is hard, typically. So what to do? We typically simply build a data warehouse on top of the blockchain data. So we literally extract the data in another system, but then we lose integrity of this data in the process of extracting it. But we will see that with Ledger table, we can use them to kind of at least not really solve completely, but solve a little bit of this part of the problem. And then finally, another thing is that the whole technology scenario is still a little bit immature with the tooling and the development and develop one of these blockchain solutions. It's becoming every day. It's becoming more and more better. All of the tooling is maturing more and so on, but it's a new relatively new technology. So things needs to, how can we say, settle down. They need to, become more and more used and more troubleshoot and debugged. And so also ad hoc solution needs to be standardized in frameworks and things like this. So these are all of the problems with a real blockchain scenario. And this can be overkill, especially when you can have simply a solution that you agree that is centralized, and you can make some compromises, of course, then you can simplify a lot of things. And this is where Azure SQL Database Ledger, or more appropriately Ledger tables that are now available also on the on-premise version, comes into the picture. So it makes data in SQL Server tamper evident through cryptography. Basically, you cannot tamper the data because the system keeps tracks of all historical changes through cryptographic proofs. We will see them. They are simply digest hashes of blocks, basically, but this provides you a way to guarantee that data has not been tampered, which is key when you have a central solution. And of course, this on Azure SQL Database or on premises since SQL Server 2022 that was released in community technology preview since a couple of weeks, 10 days, something like this at build. So it's now available also on premises. You can test it also on premises with some compromises, of course, but it's available. So let's delve into the technology and give a couple of definitions before going into the demo. The whole technology is based on ledger tables, and there are two kinds of ledger tables. The first one is the updatable ledger tables, which means simply that you can insert, update, and delete rows in the table. Behind the scenes, an history table is created, pretty much kind of like with temporal tables, and all of the modifications are preserved in this historical table. Then the system also creates what is called a ledger view, which is an easy to query view just to go and see transaction inside. What happens behind the scenes? The integrity of all of the data, both the current data and the history data, is maintained through cryptographic links in the database ledger. And we will see a little bit more in a couple of minutes. This is what is called the database ledger. Okay. The system can then be automatized to periodically upload digital receipts to a customer configured trusted storage. And we will see which kind of storage are available. And I have to tell you immediately that this kind of automation works only with Azure SQL Database, not with the on-premises version. In that case, these digital receipts needs to be handled manually. These receipts can be sent also to customers, and they can use these receipts at any point in time to verify the integrity of data. Okay, this is the first kind of tables, updatable table. The second kind, it's basically the same things, but it's append only. Okay, so you can only insert in this table. You cannot delete, update, you cannot modify anything. And in this case, everything works in the same manner, except that you don't have the history table because there's no history to record because you cannot do any modification. So to give you a little bit more context about the database ledger, as I said, it incrementally captures the database state. So the cryptographical mechanism doesn't work on a table by table basis. Digest cryptographic proofs are not generated by each transaction for each ledger table. Instead, it is created for the whole databases, for all of the ledger tables inside a database. So at the logical level, it's simply based on blockchain concept and Merkle tree data structures. With one caveat, it also captures transaction metadata. So not only the data values, but also things like the timestamp when the transaction occurred or the user that did the modification. Things like this are all of this metadata is hashed also with the data. The block and transaction information are available to the DBA through some system tables. These are the two main tables, and each block is closed either every 30 seconds or by manually executing this system store procedure. So it is not always, it runs continuously, but it appends digest in the blocks, but then blocks are closed automatically behind the scenes. This is to make the whole system more efficient. So what are these cryptographical proofs? They are what are called database digest. Is basically a hash of the last block on the ledgers. It represents the state of all ledger tables since they are linked them through these Merkle trees. Okay, and this digest must be kept in a reliable and immutable storage. Why? To prevent further tampering, because one way of tampering is tampering the data, and another way is to try and tamper the digest, the digital proof. Okay, the digest can be generated manually or automatically, as we have seen. And when it's automatically generated, you can also save it automatically only with Azure SQL Database. And in this case, you can save it either in immutable blob storage or in Azure Confidential Ledger, which is a service, a complete technology to build ledger technologies outside of SQL Server. So it's not SQL Server related, it's not transaction related, it's simply an open technology to do this kind of solution. So speaking about this reliable or private storage, what are the difference between these two targets that you can choose directly when you configure the thing? So the immutable storage is immutable, but based on policies. So you have to change the storage, you have to change the permission on the container, and you have to simply say that it cannot be changed. It's write once, read many, but you have to provide a policy. So anyone can revert and change the policy and admin, basically. While Azure Confidential Ledger, it's also based on a metaphor of write once, read many, but it's permanent, it's durable. You cannot simply change it. As I said, blobs can be set as read only for a specified range of time in blob storage. In Azure Confidential Ledger, blobs are written in Ledger and cannot be edited at all. So the data in the immutable blob storage is blocked only functionally by a policy, while Azure Confidential Ledger uses tamper-proof confidential enclave. So it's another step further with technology to kind of secure the whole system. In the other case, the case of immutable blob storage is simply a policy that can be changed. So for immutable blob storage, we can still audit if someone changes the policies around the storage or something like this. But again, you know, it's a chain. Then we need to trust the administrator that created the logging that can eventually stop it and do something. While in Azure Confidential Ledger, it creates central serialized files and transaction receipts that can be verified directly by customer, and there's nothing that can be basically changed. Everything is locked down. So with immutable blob storage, you are actually saying that Microsoft is the trusted compute base. So you need to trust both Microsoft and whoever is handling and is administering this part. While with Azure Confidential Ledger, Microsoft is completely outside the trusted computing base because the source code is open source and is done by a confidential consortium framework that it's defining how the confidential ledger needs to be secured. So when we have created the digest, what can we do with this digest? What can we do if there is tampering? We do ledger verification. Let me point out something here. So the whole system already blocks everything. So once you have a table which is append only, there's no way around it. You cannot, I don't know, go around with T-SQL commands, elevating privileges in T-SQL, go around and modify data. There's no way to do an update with a trace flag or something. It's impossible to do it. The system really prevents you, forbids you to do this. But tampering is still possible, at least at the theoretical level. So, especially if you are on premises with the version in SQL Server 2022. Why? Because in this case, you can basically shut down the service and edit hexadecimally the files, and you can simply change them. Or you can use the BCC write page, which is not available in Azure SQL Database, but it's definitely available. And I have a demo. I hope I have enough time to run the demo. But you change the data with the BCC write page on premises. And then there is also the possibility that through some bugs, someone is able to hijack the process and can, in the end, tamper the data, although it's forbidden. So exploiting a bug or something like this. So there are many cases where tampering can occur. And in these cases, we need to run verification, which basically recomputes all of the hashes and compares them with the digest that you have saved in an immutable storage somewhere else. Okay. When you have to verify all of this data, when it's necessary, basically. So if you suspect that tampering occurred, or maybe if you have a formal audit that needs to be done, or if you have a litigation with your customers. Let's say you have a process where you can, when there are litigations with customers, you simply tell the customer, give you back the digest I sent you, for example, and we will check that data was not changed from our side at any point in time. Or maybe you can simply verify on a recurring basis, daily, hourly, whenever you want to check that nothing happened. Verification via system store procedure depends on the saving mode. So it can be automatic if you pass simply the blob storage address and the system checks it for you, or you can do it manually. In this case, you simply extract with a store procedure, the same store procedure that extracted the JSON. You save the JSON, you take the JSON back in text format, and you pass it as a JSON document to this store procedure, and it will verify the whole database. Okay. Another part before going to the demos, which is very important, is the ledger auditing. There are new audit events that have been audited to SQL Audit just to trap all the ledger activities. It's important because this way we can see if something changed in the ledger configuration, something like this. Okay. Now, let's go to the demo. There will be a lot of demo. I prefer to do demos. The demos are recorded, and also in the slide deck that I will release after the session, I will unhide all of the screenshot of most of the demos, not of the tampering one, but all of the other. They will be available also for quick checking without having to go the whole presentation. So first thing, let's see how to configure ledger table. So you usually do it during creation, or you can also do it after creation. Let's say this: when you create a new Azure SQL database or a new database in Azure SQL 2022, the database is simply already able and to create a ledger table. You have to do nothing if you want to do ledger tables. But when you are creating it in, especially in Azure, you will have a special card, configuration card under security that you can go back here, or it will be presented when you are creating the database. And let me check it. Security ledger, it's here. Let me make a little bit bigger the fonts. Okay, when you are creating the first time the database, you can enable for all future tables the functionality, which means that in this new database, every new table that will be created will be a ledger table, an updatable ledger table by default. This is the only property that you cannot change once the database is created in Azure SQL Database. Okay. Then you can decide what to do with Digest storage, and this is something that you can come back after creation and change it and configure it afterwards. So this regards the auto storage of the digest, creation and storage of the digest. So you can choose whether to put it in Azure Blob Storage, in which case you have to specify a storage account where a storage container will be created for you. And then you simply have to follow the guidelines to make the policy to make it immutable. Otherwise, you can also save it in Azure Confidential Ledger. And that's it. It's as simple as that. Then we will see in a minute how to create the ledger tables. But this is the only part, configuration part in Azure SQL Database. While in, let me go to the other demo screen. While in the on-premises version of Unit 2022, so it's a new functionality, when you create a database, you can specify with ledger on, in which case all of the new tables will be ledger tables. You cannot create tables that are not ledger tables. And by default, again, they will be updatable ledger tables. Okay, in this case, we are not connecting to the on-premises one, but let's connect to the one in Azure. And let's also change context to the LG demo. And let's see how to create one of these ledger tables. 1 second. Sorry, I forgot to start the database. So that here there is a good part and a bad part. The bad part is that we will have to wait a little bit. The good part is that serverless Azure SQL Database tiers are supported. So sorry, I forgot to start using the database. So now the database auto-closed. It's configured to auto-close every after 1 hour of no activity. And so now it's starting up the database. Unfortunately, the Management Studio is frozen while we wait. Otherwise, I could have showed you the how to create it in 2022. It will take a minute. Maybe let's make it like this. No, okay. Hopefully, it was not too much to wait. So let's create a schema in the database. And this is just for, you don't have to, it's just as an example. And then let's create the table inside this schema. The thing is that you have to use these keywords, system version equal on and ledger equal on. And this will create immediately an updatable ledger table. You can specify pretty much like with temporal tables, the name of the history table and the name for the ledger view that is created, that is associated, but you're not required to do it. You can, but you're not required to do it. If you don't do it, the system will simply create with some strange names. And if we go also in Object Explorer, you can see immediately here that we have the ledger table created, type updatable, and you can see this is Management Studio 19, which is also in preview, which supports completely all of the ledger tables, also in the Object Explorer and things like that. So let's now insert a row in the updatable ledger table, and then let's make another transaction which inserts 3 rows in a single transaction. So first thing, I wanted also to show you the names. So let me open the table. You can see this is the name of the main table, and this is the name of the history table, which is automatically given by the system. I wanted to zoom, but I'm sorry, I'm not sure why Zoom it is not working anymore. So yeah, it's small, but it's one of those strange names that the system assigns. So now let's try to query the ledger table. You can see that it returns the same schema that we have defined, but we know that behind the scenes we have some additional metadata. So this metadata is not returned by default when we do select star. This is just not to break applications. It's a good practice, like with temporal tables, the columns are simply hidden. Okay, it's not a good practice to do select star, but that's another story. Then if we select specifically the columns, we can see, and we can see here that, so this is the transaction ID of the first transaction, the first instant. Remember, it was a single transaction, while the second transaction, which has a different ID, different starting ID, now inserted 3 rows. And we can see that this is the sequence of the commands in the same single transaction, okay, that inserted the 3 rows. So the sequence number is relative to the transaction ID. Now let's update the balance of customer 1, which is Jones, and from 50 we bring it to 100. Okay. And let's also explore the metadata if we want to see where are the history tables and the ledger view name. This is the way to do it with T-SQL instead of going in the Object Explorer. Now let's query the whole 3 schema objects. So the table, the original table with the metadata column, the history table, and then the ledger view. And let's see what they return. So we already saw the first table, kind of, but you can see that now one of the row changed. So it's a new transaction ID with just sequence number 0, which is the new, let's say, transaction that brought the balance of Jones from 50 to 100. Okay. When we query the historical table, we can see the old value. So we can see the old start transaction ID, the end transaction ID, which is the same as the start transaction ID of the current row, current version of the row, and then the start and end sequence number. And you can see here we have the previous value, which is 50. So we already have not only a tamper-proof technology, because we will see that is also tamper-proof, but we also have a technology that provides auditing features, pretty much like temporal tables, but on steroids, because we can also prove that no one tampered with them. And the system also prevents doing things like changing the data inside the history table. You cannot do it. While with a temporary table, you can do it. You have to take away the system versioning, update the history table, and then bring it back. You configure it back. And of course, you can also put audit event to at least know that this happened. But with this technology, it simply cannot be done. You cannot go and change the history table. There's no way around it. You cannot bring the table from updatable ledger to a regular table and then do the updates and then recreate it as an updatable ledger table. There's no way around it. Okay. And finally, with the ledger view already puts all of the things together, and you can see we have the original row with the original transaction ID. We also have the operation type. This was an insert, and we can see that the transaction that brought the balance to 50 was not a simple update operation, but it was a delete followed by an insert. Okay. So we have all of the information to run an audit, basically. Now, let's see an append-only ledger table. It's pretty much the same thing, but in this case, we are only specifying ledger on, append-only equal on. We don't have to specify a history table. There's no way, there's no history table, basically, because we are only appending in this table. So let's try to insert a row here. And let's go and see our metadata also. In this case, only 2 rows are added to the ledger tables because we don't need to handle history. So only 2 rows are added and are available. And you can see this is the start transaction ID, and we have the data. If we try to update it, there's no way around it. Updates are not allowed for the append-only ledger table. It's not you don't have permission and then there's a way to grant it somehow. There's a database role, a super role at the instance level that can let you do something like this. Maybe there is a trace flag, I don't know, for sure. No, I don't think so. But the key point is that you simply cannot do it. There's no way around it. Other operations are allowed. For example, we can rename the table. And in this case, you can see that the table was renamed. And we can also drop the table. If we drop the table, in reality, the table is not dropped, but it's simply put in another, because otherwise we are deleting evidence and we cannot go back and verify the digest. That remember, it's at the database level. So we need to keep the data around. And in fact, when we drop the table is simply it's simply flagged as a ledger table that was deleted, but it's still available here. Okay. And this is the name. It has a different name. And if you try now to drop again the dropped ledger table, that as you can see changed, of course you cannot do it. Otherwise there will be a way around this. Okay, so this is just, I did it step by step to give you the confidence that the whole infrastructure is reliable. You can trust it that there's no way around. Okay, still remember that things may be changed. We will see it in the on-premises version, but there are always bugs. Maybe a bug in the future could arise, and maybe someone managed to exploit it and managed to go and do something. Another thing which is very theoretical is that someone with very broad administrative rights could go and access the data storage inside Azure. But this is practically impossible because the Microsoft has a very tough layering mechanism also when they have to do some simple troubleshooting. So I said it, the Microsoft need to be trusted at some point, but it's in practice that there's no way around it. A bug, it's more probable in this case. Okay, let's have a look also what's inside the system table I mentioned. So here you can see all of the blocks that are handled automatically. As I said, they are closed automatically every 30 seconds, or you can invoke a system store procedure. And these are the internal hashes that are generated. And if you want, you can see also the details of the blocks. So now let's move on to digest verification. So how do we verify the digest? So the first thing is, if you don't want to poke around with Management Studio or things like this, we need, sorry, let me, don't find it. Okay. You can go simply on Azure portal, and here where you have security, again, the security configuration, you have verify database. And here you have the T-SQL code you can copy in Management Studio to verify at any point in time that no one tampered with the database. In this case, the query is simply it's simply taking where the digests are saved and taking the digest, the last digest from the storage, and verifying with that last digest. Okay, this you can copy the code in Management Studio, or you can also do it now from the query editor, which is in preview from Azure portal. So let's try this. Let me log in, and I can simply run the code, and query succeeded, and verification succeeded. Okay. Hopefully, it is already, I think, in the roadmap. We gave a lot of feedback on this. Hopefully, there will be a way to schedule directly, checking the verify the database on a recurring basis. Right now, you have to schedule it somehow with one of the usual mechanism to schedule the execution of any kind of query. The same code, if you run it in the SQL, you can see that it does the same thing. So it takes out from the digest location this, which is the pointer to the blob storage, and with the last digest block ID. And then it's simply passing this to the store procedure, which is simply checking this, and ledger verification succeeded. What if you cannot do it automatically like this, or if you want to provide your own mechanism of doing the verification? You can simply use this store procedure at any point of time to get the digest. This is the same digest which is saved in the blob storage or in Azure Confidential Ledger, and you can save it in your immutable storage. For example, this could be a write-ons, a worm, a write-ons media, optical media on premises, which is really mutable because you cannot really overwrite it in any kind of manner. So your application needs to provide this. So it needs to invoke this store procedure, and then needs to save to this kind of devices the JSON, the result in JSON. Then at any point in time, you simply can read back the last digest, or any digest for that matter, and simply call the verify database ledger to check that it was verified. There's no error, so it's okay. If we change anything, like let me put something like this, a 5, you can see that it didn't match. So if someone tampered the digest, or the data, it will result in an error like this. So let me show you now another thing. This is the new part, because I did this presentation already 4 times in Italian language, and I didn't want to do it, but then they released 2022, so I said, yeah, why not? Let's make it another time. We will show how to do some tampering for real with the on-premises version. And so let me do this. Let me create database in the on-premises version. So there is a need to run verification in the on-premises version. We need to allow snapshot isolation in the database, not a read commit snapshot isolation, only snapshot isolation, which is already on in Azure SQL Database. Then let's make the same thing. So we are creating the same table we have just used in the last example, which is an append only table, and we are going to insert this value. Okay. Then let's generate the digest and pretend that we have put grid, which is faster. Okay. Let's pretend that we saved the digest somewhere in a custom storage. You can see the digest verify. This is simply the first digest. Then let's try to update. Let's say that this employee ID is the DBA and wants to change the hour when he entered this building because he did something he shouldn't have done and things like this. So let's try to do this. Of course, if we try to update, it fails because it's an append only ledger tables. But the DBA is smart enough, so he knows how to get the page ID of that row. And he knows how to generate the var binary representation of the same hour, of the same date time too, but 1 hour, what is it? Sorry, 1 hour before in advance. Okay, so let's check this. I inserted it. Yes, I changed it. I'm not going to tell you why we have different numbers, but it's because I made some last minute change. Okay, and you can see this is the binary representation and this is the page ID. And then with some completely unofficial, undocumented comments that some people would also like to keep them hidden because you can really screw things. So don't use them usually. But it's very simple to find this kind of information online. They leaked since more than 10 years now, so I will show them to you anyway. It's very simple, and it gives you the idea of how simple it can be to do this kind of things. It takes 1 minute to search this kind of documentation on Google and data if you are a sysadmin in the on-premises version of SQL. So you need to have the rights to run right page, basically, which you don't have when you are running in Azure SQL Database. But this is on-premise, so we have the this permission. So this is the data that I need to write. I needed to write in this page, in this file of this database ID. Okay, and this is the offset where I'm going to write, and these are the number of bytes. You have to poke around to see these things. So you have to do this, and then you have to search where the data starts, starting from the slot numbers, things like this. But it's very easy. Okay. So now I do the right page. Okay, as simple as that. If I now select the data, again 69, no last minute changes before doing demos. So you can see that now the data changed. I took back 1 hour, and the original data, remember, is this one. Okay. So I was able to effectively tamper the data. But since we have our digest that we saved somewhere in an immutable storage, I can check it and at least know that something has been done. You can see now that the computed hash does not match for this transaction ID. So I now know that someone tampered with my data. and I can go and then what to do? It's hard, tell you, because once you find out that someone tampered with the data, what happens? There are two scenarios. In one, you have to restore basically your data because you want to go back to an exact state of your database. And this means missing transactions that were done after the fact, after the tampering. Also, even by going back, let's say that you don't go back. Or you go back, it doesn't matter, it doesn't really matter. If the transaction was not only written in this database, but also fired a chain of the event outside of the database. So the application simply wrote something here, and then a huge amount of operations were done with several different systems outside of SQL. If we go back in time and we restore the database to that point, not only we lose the transaction ahead of that time, but also many things happen in another system that we may not need, we may not be able to roll back. And this is a serious problem. What to do? We don't go back in time, we don't restore, we accept the tampering. That's one way. For sure, we cannot go and change back the data unless we use the same right page. So we use an official way to do it. So it's a tough problem. It's not an easy just quick solution what to do when you find tampering. Unfortunately, it's not a functional a problem that you can solve with the SQL statements and functionalities. It's something at the process level, at the application process level, that you need to know what to do, and you need also to know that in some cases you will not be able to do anything or that you would have wanted to do. So this is pretty much everything about the demo. And so let's go back to the presentation for some final consideration. So as you may think of, this is the first release of this functionality. So in typical Microsoft way, V1, it's useful, but still has quite a few limitations. That may be removed in future version, future releases, or may not. It depends on how much people will use this functionality and how these things will be prioritized. And if, of course, you ask Microsoft to remove them at some point because you need it for some business case, a real business case scenario. So there are quite a few limitations. For example, we cannot disable the forcing of creating all tables as ledger tables at the database level. Once it's on, it's on. You have to drop the database and create a new database and move the tables. That's it. So usually you don't want to do it in production. It may be a hassle when you're doing it in development, because once it's turned on, you have to throw it away if you want to create regular tables. There's no conversion of existing tables both ways, so you cannot convert a regular table to a ledger table and vice versa. So what to do? You have to create a new table and use this system store procedure to migrate into the new table, and eventually you simply rename it. And this is the way. There's no dropping of tables and or columns. So when you drop tables, they are simply renamed, as you saw, and they are put in a folder in Object Explorer. It's simply a column, a bit column with additional metadata. This is in the case of tables. In the case of columns, they are simply hidden. They remain available for database verification. Otherwise, if you drop them, you cannot verify the database with your digest, of course. So they need to stay somewhere. They are simply hidden, and they are not returned when you do select. You cannot delete all their data from history table, and this may be a problem because you're accumulating data, and maybe you simply want some quick way to have a retention and to delete the data. You cannot keep adding data forever. In this case, you are forbidden. You cannot. You have to keep it forever around it. Transaction can only update 200 tables in a single transaction. Okay, this is, I think it's usually it's not a limit. And then update ledger tables are based on temporal table technology. As you have seen, there are many similarities. And so they also inherit most of their limitation. It's a long list, so I'm not going through every single limitation. You can read it up. I'm simply pointing out other limitations that are key, like interoperability limitation within memory tables that are not supported. If you're using partitioning, you cannot switch in and switch out partitions. Full text indexes are not supported. Graph and file table types are not supported. You cannot have a non-clustered row store index when you have a clustered column store index on the table. There's no support for change data capture, so you cannot use it. You can use change tracking, but it's not allowed on history tables, and I haven't tested this, so I'm simply telling you what's in the documentation. Then there are other schema limitations. Some of them, as I said, there are others that are tied to temporal tables. We have a maximum number of columns is always 1024, but remember that updatable tables requires 4 columns, so it's 120, or append only ledger tables requires 2 columns, so 1022. Okay. You can add nullable columns, but you can add columns, but they need to be nullable. You cannot specify with values. Nulls are treated as nothing, and so they don't come into the calculation of the digest. So there's no problem. But this is why you can add them, but you can only have them null. Imagine what would be if you could specify a value, all of the digest, since the digest is at the database level, would be invalid. Okay. You can alter columns, but this is limited to nullability and the length of variable length column types. Then you can also change the collation only for Unicode strings. And then there's no support for special type like XML, file stream, SQL variant. You shouldn't use it anyway, we know, and user-defined type in general. Okay? And then finally, sparse column set are not supported. The sparse attribute should be supported. I didn't test it recently, so don't take my word as for sure. Test it out if you're using this functionality, but the sparse column set is not supported. So what are some of the use cases for ledger tables? In general, all of the scenarios where forward integrity is needed. So you need that the system is reliable while processing transaction and is protected against future tampering. And you have a typical centralized scenario where you are already doing this kind of, let's say, compromises. Okay, and some examples can be streamlining audits, make it simple for doing audits. You have seen, you have the history table for updatable table. You can see the history of transaction when they change it, what were all of the operation. You have the metadata, and this comes for free with the additional benefit of being able to verify cryptographically to prove that no one, to auditor, to external or internal auditor, that no one tampered with the data, that the data is still reliable. Okay? Another example can be multi-party business processes where you have to coordinate with external entities and you want to give a reasonable assurance of tamper proofing, but it's like a trust but verify perspective. So it's not don't trust anyone. In these cases, this technology works. I mean, if you have, why you have to resort to blockchains, to full blockchain technology, so to a fully distributed blockchain kind of pattern. when you trust no one. In typical blockchain scenario, the assumption is that you don't trust anyone in the process. But this is not true in many cases. In many cases, you are simply partnering with other companies which you trust to a certain level, but you never know. So you trust, but you want to verify through audit at a certain point in time. Here you're making this compromise, but it's a huge compromise. I mean, it's huge. It's huge because you have to trust, but it's also huge because it simplifies a lot of things. And for example, all of the off-chain problematic, it's dramatically simplified because you can query the data and do certain kind of queries on the data, analytical queries directly without having to extract them and things like this. Or it can be a solution for this specific pattern. You still don't trust anyone, so you still want to implement a full blockchain scenario, but you want also to run a data warehouse and analytical queries on data which is already organized as fact and dimension and is very fast to do this kind of data. Of course, you have to extract the data from the chain, but one thing is to extract it to regular tables that can be tampered. Another thing is to extract it into ledger tables, maybe append only, that cannot be tampered and can still be queried. And through digest, anyone can still, of course, someone can intersect the extraction process and tamper the data while extracting the process. But the data that was already written in the off-chain database, it's still there and it can still be verified that no one tampered with. So it's still a good solution for this scenario, in my opinion. And then I will leave you also this good post by the former PM of the functionality on what to consider when choosing Azure Ledger technology versus regular blockchain technology. So these are some of the resources to start using it and start digging more into the functionality. And thank you, everyone. If there are some questions, please write them. I'm monitoring them. Otherwise, you can also you can always write to me afterwards. So there is a question: is the value on history table used as before image by select? Selects when updated row is locked. I didn't check this. It's a good question. I didn't check this. It should be, but I cannot assure it. I'm sorry, I don't know the answer to this. It's a good question, and you have to try. Hopefully, it's very simple to check it, but I don't have a straight answer. I can tell you. While wait for other questions, if there are any. I can tell you that I was brought on the beta quite early, but I was able only to run a project with customer when it was in preview. So I don't have such an extensive experience with real hands scenario like high throughput scenarios and things like this. This scenario, it's a scenario that is going to be presented publicly next week to the lawyers order here in Italy. And it's a scenario where we are using the technology to basically to render tamper-proof some JSON documents which represent the privacy consents that is given by people. And so the digest is also sent to customers. It is embedded in a PDF which contains also the all of the flags that customer checked for the consensus. And that's pretty much it. It's a very simple and very, let's say, specific scenario. So it's not the kind of regular transaction processing or there's a scenario where you have thousands of inserts per second and things like this. So unfortunately, this means that also I touch everything I could think of, but I didn't run any workload and checked the locking stuff. But it's a very good question. Thank you for asking. Sorry that I don't have an answer for it.